Let us study what is meant by sp3 hybridization. In order to explain this, there are different steps are used. For example, the question can be asked, explain the hybridization involved in methane. Which are the bonds present in methane? How many sigma bonds are present in methane? 5 marks question. Therefore, let us see how to follow, and the diagrams are very important. You please refer the diagrams in the textbook. I just draw the diagram, but in order to draw the correct neat diagram in your notebook, it is better to refer the textbook, the diagram, and then draw it. Now, first step is that the formula methane. Write the chemical formula of methane and write the electronic configuration of carbon. According to the Aufbau principle, the electronic configuration is 1s2, 2s2, 2p2. Now, in the ground state, represented by the electrons, that means 1s2 means 2 electron, 2s2 means 2 electron, 2p2 means in 3p orbitals, px1, py1 and pz is empty. This is very important, all the representations. For each step the marks are given for it. Now this is the ground state, that means as in the electronic configuration. Now excited state means the atom absorbs energy and the electron get excited, that is from the 2s2. From the 2s2, one electron get unpaired and goes to the p orbital. Now in the p orbital, three electrons or the three p orbitals are half filled. All the three are possessing electron and 2s is having one electron. This step is very important. From this step only, either you can take an sp3 hybridization, or you can take sp2, or you can take sp, depending upon what we select. Now we are going to select 1s, that is from the 2s orbital, 1 orbital, and from the 3 orbital of p we are taking all the 3. Therefore 1 plus 3, that is 4 orbitals before hybridization, subjected to sp3 hybridization, that means 1s orbital and 3p orbital, known as sp3 hybridization. After the hybridization, the representation is another important factor. The hybridized state 1s2, there is no change, but the differences in the energy between s and p disappears and we get 4 hybrid orbitals, all are having same energy. Therefore draw 4 columns with unpaired electron, and below each orbital write sp3, 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 sp3. It is important because 4 sp3 hybrid orbitals all are having equal energy. Now the 4 sp3 hybrid orbitals of equal energy and identical shape, their shape is also same. The hybrid orbitals are directed towards the 4 corners of a regular tetrahedron at an angle of 190 degree 28 minutes with the carbon atom at the center. That is the diagram with the shown here. This is the tetrahedron and the shape is s and p orbitals undergo hybridization, and the p is having a dumbbell shape. Therefore the characteristic is of the shape is adopted from the p. That is why this is having a shape like this, and this is a tetrahedron. The 4 hybrid orbital, this is 1, 2, 3, 4, are directed towards the 4 corners of a regular tetrahedron. These are all hybrid orbitals. This is sp3. This is sp3, sp3, and this is sp3. And each sp3 hybrid orbitals will overlap with the oneness orbital of the hydrogen atom. This is the hydrogen atom. Hydrogen. These are the 4 hydrogen atom. That is how and the center one is carbon. The central atom is carbon. That is why the formula CH4. CH4. And one of the most important factor is that when 2 orbitals undergo overlapping, this is called head-on overlap. If it is this type of overlapping is called head-on. If it is head-on overlap resulting in the formation of a sigma bond, head-on overlap, head-on, that is called head-on overlapping, it is called sigma bond. Whereas if it is a p orbital, that p orbitals, it can undergo head-on overlap. If 2 or p orbitals, they can undergo also head-on overlap, but they can also overlap like this. See, if this is an px, always undergo head-on overlap. If it is px, if it is py, it can overlap like this. This middle is the node, and only the top and the bottom undergoes overlapping called the sidewise overlap. Sidewise. And even if it is in an z direction, that means pz, that can also undergo overlapping sidewise. Any sidewise overlapping result in the formation of a pi bond. Any sidewise overlap always result in the pi bond. That means that we are going to discuss next. Before that, you must have an idea. Head-on overlap result in the formation of sigma bond, and sidewise overlap always result in the formation of pi bond. Here, look at this. All are head-on overlap. There is no question of any sidewise overlap. In methane, hydrogen overlap with the hybrid orbital of the carbon. Hydrogen, here also head-on overlap. Head-on overlap. Therefore, this is a sigma bond. This is a sigma bond. Sigma bond. And this one also a sigma. 4 sigma bond. Therefore, in methane, there is only 4 sigma bond. Now, the angle is important. That the angle HCH is 109 degree 28 minutes. Second point. Third point, shape of sp3 hybrid orbital, tetrahedron. These 3 points are very important, and even the diagrams. Now, similarly, you try to do another example, ethane, having sp3 hybridization. Only difference is that 2 carbon atoms are used. You separately write all the electronic configuration as it is shown. 1 carbon atom, you write another carbon atom also. 2 carbon atom, you write the electronic configuration. And the tetrahedral, this corner, sp3 hybrid orbital overlap with another head of the tetrahedron of another carbon atom. That is the only difference. That means you will get 2 tetrahedrons like this, and one tetrahedron is pointed towards, this is the one tetrahedron carbon atom, and another one you will get like this. This is another carbon atom. This will join here. That is carbon, carbon, 1 sp3 hybrid orbital. sp3, 3 hybrid orbitals will have 4 hybrid orbitals. One is utilized for the formation of carbon, carbon. This is carbon. This carbon and this carbon is connected like this. The rest are all hydrogen. Hydrogen overlap, hydrogen overlap, hydrogen overlap, hydrogen overlap, and hydrogen overlap. Try to do by yourself, and any doubt, please refer the text and do it by yourself.